me, this is my bread and butter, I guess. It's what I like more than anything. I'm passionate about the cardiovascular system and the way it operates. Thank you, sir. Without the cardiovascular system, we don't function. We're not here. We have to have the brain, because that's the computer system that operates everything. Without a heart, we can't pump the blood. We don't pump the blood. We don't perfuse the cells. We don't perfuse the cells. What happens? We die. Okay? So the cardiovascular system is very important. A lot of the stuff we've already talked about, like last week on the respiratory system, we've seen where they work together, and they do. And we're going to talk even more about that tonight as well. But everything we talk about from point forward, when we're doing patient assessments, when we're treating patients, talking about diminished LOC, whether it be a myocardial infarction, whether it be diabetes, whether it be trauma, whatever, we can carry it all back to the cardiovascular system. It's the core, it's the heart, literally, of the entire system. So I'm passionate about it. I think it's something everybody should understand. And so we take it from a very simplistic point of view. We're going to go step by step and work through it. I want y'all to be drawing. If you've got paper, if not, we'll get you paper. Draw what I draw on the board, because we're going to talk about the circulatory system and how it operates. There's 18 steps to the circulatory system in order from where it starts to where it ends. We're going to talk about the electrical conduction system from where it starts and where it ends, and what happens if there's a problem in that system as well. What we can do as EMTs to reverse or correct something that may be going on, or it may be something we can't do anything about, but we have to be able to recognize it. CPR is fun, okay? We pump the chest, but why do we pump the chest? We breathe, but why do we pump the chest or breathe for them? We put the AED on there, but what are we doing when we put the AED on there? We're not electrocuting the heart, okay? We're not jump-starting the heart like people say, okay? We're going to understand what the AED does and what rhythms it will work on and what it will not work on, okay? So I recommend that you close your books, because I'm not going with the book at all, okay? The book will just confuse you, but the book is very important. Like I said the other night, you will not pass the course or National Registry if you have not read the book. Everything in my lecture tonight will cover what's in the book in a different sequence, in a different way of presenting it. The book is important. You have to know what the book says. Okay? But you also need to understand the cardiovascular system from a simplistic point of view. And that's what I'm going to give you. Let me turn this air conditioner down a little bit. To me, it's hot in here. Here. You hand out paper if you're drawing pictures? Take one, pass it around. Okay? So, the first thing we're going to do is we're going to diagram the heart. And we're going to talk about the different parts of the heart. It's going to be interaction, okay? There is no wrong answers. If you don't know, but you want to take a guess, okay? But by the end of the evening, we will all understand what the heart is made up of and how it's made and how it operates. That's the goal with this, okay? If I get too fast and you get confused, stop me. I'm going to try to start point A, and we're going to end back to point A. We're going to go through the entire system. We're also going to talk about the pathophysiology of some of the cardiac syndromes and some of the other diseases that we deal with: congestive heart failure, acute coronary, MIs, congestive heart failures, right and left heart failures, pitting edema, pulmonary embolism, thrombosis, arteriosclerosis. All those terms are in the book. If you read the chapter, we're going to be talking about that and what is happening to make that happen. Okay? So, before we start anywhere, we've got to understand what the heart is. And I'm going to start with Maurice. What is the heart? What's it consist of? One word. Just one word. What is the heart? Starts with an M. It's a muscle. That's what we need to know. It's a muscle. What type of muscle? It's myocardial muscle. It is the only muscle in the heart made up of its specific tissue. The tissue that's made up in the heart is not anywhere else in the body. Okay? We'll talk about that more shortly when we get into the conduction system. But the heart is a muscle. If you work in the oil field, or if you're anything around mechanical stuff, it is a pump. The heart is nothing more than a pump. For the fireman's sake, it's a two-stage pump, basically. Okay? It's right and left pumps. So with that being said, we're going to draw a picture of the heart. And here's my famous heart. Everybody knows it, okay? There's my famous heart. The top of the heart is actually called the base, if anybody ever asked you. Okay? The base is at the top of the heart. The apex is down here at the bottom. In case anybody ever asks. And you may not see that on a question, but it's good trivia. Okay? Most people say the base is at the bottom. The base of a building is usually at the bottom. The base of the heart is at the top. A little more trivia. Why that happens is when the heart is first developed in the fetus, it is actually rotated. So when it's actually first developed, it is the base is at the bottom. But through the 9 months of gestation and as it grows, it actually rotates. Okay? The apex becomes the bottom and the base becomes the top. Just trivia stuff.
How often?
Huh?
How often?
What it just rotates one time, but it's usually within like the first 6 weeks of the baby's life. Okay. But when the heart beat starts beating, the single little chamber is actually inverted, and it inverts or changes during life cycle. Okay. The heart is made up of 4 chambers. Okay? We're going to look at this heart from the anatomical position, as if you're looking at me. Okay? So, this is my heart. Yes, it's black. Okay? This is my heart. So, we're talking right side and we're talking left side. So, there's 4 chambers. We start out with the right atrium. We're going to label these in a minute. Okay? But we just call RA. We've got the right ventricle. Go to the left side, we've got the left atrium and the left ventricle. Okay? All 4 of these chambers have very important jobs to do. So it's very important that we understand, anatomically speaking, what chamber is where. Because if there happens to be a problem in the left atrium, we need to be able to recognize what the physiology or pathophysiology path to the problem is based on that problem. Okay? What's going to be the outcome if somebody has left atrium heart failure? What are we looking for? Or right atrium, or left ventricle, or right ventricle. Okay? So we have to understand the chambers of the heart. So this is our base heart. This is where everything comes together. Or goes away. Okay? So, we're going to start talking about the 18 steps of circulation. There's 18 steps into the circulation from the time the blood enters the heart until the time the heart or the blood gets back to the heart. During this circulation, we do multiple things. We pick up oxygen, we distribute oxygen, we pick up CO2, and we distribute it CO2 or blow it off. And it's somewhere in this circulation. Okay? So, make sure you label these 18 steps in the proper order. Because, what are you going to see again? Gabby?
Probably a quiz.
Probably a quiz, and it says something about the 18 steps in order, right? Yeah. Okay? So, I'm going to start out with step number 1. Blood enters the right atrium. Okay? So I'm actually going to draw the circulation as we do this. So blood enters the right atrium. This is step number 1. Okay? And it is the right atrium. So far, so good. Everybody got step number 1? Well, I'll tell you on the quiz, I always give you step number 1. So everybody's got that automatically. But don't forget it, okay? So from the right atrium, where does the blood go? Anybody want to venture to guess? It goes to the right ventricle. You're absolutely correct. Okay? It does go to the right ventricle. But before it gets to the right ventricle, it has to go through something. What do you think that would be?
The tricuspid valve.
It has to go through a valve. Okay? There is a valve right there. Okay? Well, I'm going to stop. This is not part of the steps. But this little line I drew right here, between here, I'm just going to highlight it again in green. We call that the AV septum. AV standing atrioventricular septum. Okay? And it is a thin piece of tissue that separates the atrium through the ventricles on both sides of the heart. Okay? Right on this AV septum, between the right atrium and the right ventricle, sits a valve. And it is called the tricuspid valve. Okay? So, from the right atrium, it's got to go through what? I'm going to try to spell these right, so I'm going to just get my list. That way y'all can get them right. Since I'm recording it, it's tricuspid. The tricuspid valve.
Can you spell that out loud?
Tricuspid. Okay? And it's called a tricuspid valve because it's got 3 cusps that come down that's held by ligatures inside the heart. Okay? It's a one-way valve. Blood can go through it one way. It can't go back the other way. In oil field terminology, it's a check valve. Okay? It'll only let blood go one way. But it's made out of 3 parts, the tricuspid valve. So we've got a valve right here, and I'm just going to draw 3 of these, just so we know it's a tri, or 3. Okay? So now we know the blood goes into the right ventricle. So step 3 would be the right ventricle. From the right ventricle, we are carrying blood out of the heart to somewhere. Would somebody like to take a guess where it's going? It is going to the lungs, okay? But I don't call it lungs in this here, okay? We break it down to the place that blood actually makes an exchange. Where's that at? The alveoli. But before it can get to the alveoli, it has to go through something.
Pulmonary artery?
Pulmonary artery. Exactly. Okay? But it's not. Yeah, it is.
That was Gabby's answer, by the way. She's just not speaking up.
Okay. But before we get to the pulmonary artery, I'm going to explain something about arteries. I'm going to ask you a question. Does all arteries carry oxygenated blood?
No.
No. Let me ask you this question. Do all arteries, all inclusive arteries, carry blood away from the heart? Yes. That's the positive or the absolute. An artery carries blood away from the heart. Okay? Sometimes people will try to throw a trick question out there and say, all arteries carry oxygenated blood. Because that's what's carrying oxygenation blood to the body is arteries. Okay? And then veins carry the waste products out of the cells, the CO2, all the waste stuff, back to get rid of it. Veins carry deoxygenated, arteries carry oxygenated, with the exception of two. One being the pulmonary artery. Okay? Because, and we'll see in a minute, when blood gets here to the right atrium, it's coming out of the body. It does not have adequate supplies of oxygen in it. So we call it deoxygenated. It's oxygen negative. Okay? But we'll get there momentarily. From the right ventricle, we already know we're eventually going to the alveoli, aka the lungs, through the pulmonary artery because it's carrying blood away from the heart. But before we get there, what do you think there is? A valve, absolutely. So, on this same septum, I'm just going to do this right here. I'm actually going to draw the picture a little different. On this same septum, we have what is called pulmonary valve. Okay? This valve is what we call a semilunar. A semilunar valve. And why that is because the valve is made up of little flaps of tissue that look like the moon. Kind of half moons, basically. So we call it semilunars. Okay? It, too, works like a check valve, but it does not have all the pressure behind it like the tricuspid and the bicuspid valve. Okay? So, I'm going to draw it out the side up here just so that we know it's leaving the right ventricle. Okay? So, we go through the right ventricle, we go through pulmonic valve. We've already talked about we're going to go through, what was this called? Taylor? Where's it going through? The right what? Or it's the pulmonary artery. Yes. So, step number 5 of the circulation is the pulmonary artery. Okay, so our pulmonary artery takes blood to what we're going to draw a big picture of. The right side's going to have 3 lobes. Remember we got this tube right here that branches off in the right and left. Okay. Left side's only got 2 lobes. Why does the left side lung only have 2 lobes and the right side only have 3?
Your heart isn't like the heart.
Because you have to make room for the heart on the left side of the chest. Okay, that's the only reason you got 3 on the right, 2 on the left. So, pulmonary artery comes in to the lungs alveoli, the single cells, which we all know is these little bitty grape clusters, right? How many alveoli is in the lungs?
Thousands, billions, millions.
Billions. Okay, it's billions. And each alveoli is a little sac, okay, like a balloon, that is surrounded by arterioles and venules. Okay, and we'll talk more of those terms in just a minute. What takes place here at the alveoli?
Oxygenated gas exchange, like the
Gas exchange. What do we pick up in the alveoli?
oxygen,
Oxygen. What do we get rid of in the alveoli?
carbon dioxide.
Carbon dioxide. Okay? So I'm going to draw this pulmonary arteries going to the alveoli. Okay? So everywhere from here, from the right atrium to the pulmonary artery to the alveoli, is carrying what kind of blood? Deoxygenated. This is where I'm going to call O2 negative. Okay? It's deoxygenated, but it's O2 negative. Now, in reality, there is still oxygen in the blood. The air we're breathing right now contains approximately 21% oxygen. Okay? When we exhale, the oxygen or the air we exhale contains approximately 16%. So how much air are we using oxygen on a breath? About 5%. This is why if we have to give mouth-to-mask ventilations, we're actually breathing for somebody, we're actually giving them oxygen. Because we're breathing it in, and then we're breathing it out back into them through the mouth-to-mask. If we were using up 100% of the oxygen, all we would be breathing into our victim or our patient would be carbon dioxide, right? That is why we call it deoxygenate. It's not the 21% because it's used up. Another thing about this, if this deoxygenated blood just has 16% in it, and I'm not breathing, I'm apneic, not breathing, okay, but my heart's still beating, can this blood still oxygenate cells through the body a second time? Yes. It doesn't have as much oxygen in it. It's not going to be as oxygen rich, but it can oxygenate cells. Hence, we start CPR with compressions first because we're not going to get any oxygen to a cell if we're not moving blood. Okay? So that's why CPR always starts with compressions, not breath. Let's see, you had a question.
Yeah. Is there a valve when the blood enters the right atrium?
We'll get there. We're not there yet. But no. But we're going to get there. Okay? I'll answer your question, no. But we'll get there in just a minute. Or in a few minutes. Okay? So, we call this, to here, pulmonary circulation. We've still got one step to go in the pulmonary circulation. Okay? So, when we leave the alveoli, what do we return to the heart in?
Cells.
Veins. Exactly. So, if we had the pulmonary artery to the alveoli, what do you think we have coming back to the heart?
Blood.
Blood, but where do you think it's going through? A vein. What do you think we call that vein? Yes. Step 6, by the way, was the alveoli. I forgot to put that on there. Step 6 is the alveoli. And so we've already talked about the pulmonary vein. Would be number 7.
Is that the only vein that has oxygen-rich blood in it?
Yes. So back to our trivia questions. If anybody says all veins carry deoxygenated blood, is that true or false? That is false, because the pulmonary vein is coming from the alveoli back to the heart, and it is full of oxygen if the patient's breathing or we're supplementing oxygen or they're working like it's supposed to. Okay? So the pulmonary vein comes back to the heart. Wow. Where do you think it dumps into?
Left atrium.
Left atrium. Okay? There is no valves between the semilunar the pulmonic valve and the left atrium.
Well, Mark was supposed to do it now.
Okay? No valves between this valve here and here. But all the blood goes through the pulmonary artery, leaves the heart to the alveoli, picks up oxygen, gets rid of CO2, and comes back and dumps itself into the left atrium. Okay? So this right here we call the pulmonary circulation.
The top 7 are the pulmonary circulation.
Yes. Because that's pulmonary meaning lungs. Okay? And so our blood, the right side of the heart, its purpose is to take blood from the body, push it through the alveoli and back to the left ventricle. That's what the right side of the heart's for. If we have right-sided heart failure, what do you think is going to happen?
Your respiratory failing.
You're not going to be picking up oxygen, right? Because you're not getting it to your lungs. We'll go through that in depth a little bit later. But just know that the right side of the heart's main purpose is to pump blood to the alveoli, a.k.a. the lungs. Okay? So what do you think the other side of the heart does? What we're fixing to get into is the systemic, okay, or peripheral. That's everywhere else. That's to the brain, the liver, the kidneys, the reproductive systems, all of the cells in the body, our muscles, our nerves, everything else comes from the left side of the heart. So what do you think is the strongest side of the heart?
The left.
The left. Okay? So if you look at a heart on a diagram, or actually on a cadaver, the right side of the heart is usually thin, narrow, smaller chambers. Not necessarily smaller in quantity of blood, but in the thickness of the wall. Okay? The left side is usually bigger because it takes more muscle to pump through the entire body. Now, I am not making fun of Jesse at all. I would if Loopy was here tonight, but Loopy's not here, so Jesse's the next biggest guy here. Do you think his left ventricle is pumping or having to work harder on him than Braulio's? It is. And why is that? Because he has more body mass. He's got more area it has to pump to than him. Now, can Braulio have hypertension? Yeah, because hypertension's not determined by body size, primarily. It's determined by the way we feed our body. Healthy foods, unhealthy foods, exercise, that kind of stuff. Okay? But understand that a larger man usually has a larger heart. And ladies, it's not to take your breath away, okay? It's to pump more blood through the system. Sometimes if a person starts out small and they gain lots of weight later in life, the left ventricle has to get bigger and bigger and stronger to accommodate everything. And we get a condition called cardiomyopathy. It's where the heart muscle gets bigger, okay? And that causes problems in itself. So when you're doing patient history, you may have somebody say, yeah, I've got left ventricle myopathy. That means it's just bigger, okay? And it's going to cause problems as well. Just a little bit more trivia, okay? So we know that we've got oxygenated blood coming back into the left atrium, from the alveoli. So the purpose of the left atrium, and the only purpose of the left atrium, is to preload the left ventricle, okay? Just by normal blood flow, blood's going to flow into the left ventricle, but we preload it with an extra boost to totally fill this chamber, okay? So the left atrium pumps blood to the left ventricle. But to do that, it has to go through this septum again. And what do you think's there?
don't know where it's called.
Let's go here first. So left 8 is going to be the left atrium. And then we have to go through a valve. This is the most common valve everybody typically knows about. It's one that we have valve regurgitation. You hear of people replacing this valve with pig heart valves. And the reason being is because this is the largest muscle of the heart, or largest chamber. It creates the most pressure. And so this valve, it again is a cusp valve, but only it's bicusp. And we call it the mitral valve. M-I-T-R-A-L. Mitral. Or the bicuspid valve. Bi meaning two. Okay. So the tricuspid here has 3 flaps held in a descending order that works so the blood goes this way. This one only has 2, but they're a lot larger. Okay, so I'm just going to draw 2 triangles.
Bicuspid.
It's a bicusp.
What's the second?
What's it say above it?
Mitral, M-I-T-R-A-L.
Five or five?
Bi. Like a bicycle. Like somebody is bi, they do. Either way, either or. 2 instead of 1, however you want to say that. It's not a tricycle like this one. It's a bi. It's 2. 2 wheels, 2 flaps, 2 cusps. Okay. So we go from the left atrium through the bicusp valve or mitral valve into the left ventricle. That would be number 10. Left ventricle. Everybody got my drawing down so far? Okay. Good. That's what I want to see. So now we're in the left ventricle. And now we are fixing to take a journey. And the journey we're taking is through the body into everywhere. So this ventricle, when it contracts, has got to create enough pressure to overcome all resistance in the body to get from here to my big toe, or to get to my brain, or to get to my fingertips, or to get anywhere it needs to go. Okay? That is where we get the pulse, right? Remember when we took pulses, we talked about the pulse is the contraction, the pressure exerted against the walls of the artery at the contraction of the left ventricle. That's the pulse. When we feel it, what we're feeling is when this thing contracts, it is going into the arterial system, and we feel that pulse. Okay? That's the contraction of the left ventricle. That's what creates the pulse. It's not created anywhere else. Okay? So this has to overcome residual pressure. What pressure do we measure to see if this is working good or not? Systolic. Exactly. Systole or systolic is the maximum pressure we record at the contraction of the left ventricle. We do not record right atrium, right ventricle, or left atrium. Our systolic blood pressure is the pressure exerted against the walls of the arteries at the contraction of the left ventricle. Very important, because if the left ventricle ain't working, what's our blood pressure going to be? It's probably going to be low, okay? You may get some residual if the left atrium's pumping. All of this is failed. You're liable to get some blood pressure because this is going to work this way. What's going to happen if this fails? What's this part of the muscle going to do?
Overwork.
It's probably overwork and get bigger, right? So you're going to have an enlarged heart. The left atrium's not designed to be bigger, not even in the chest cavity, okay? So it's going to grow inwards instead of outwards, which is going to reduce the amount of volume that it's able to pump. Plus it's pumping through this, which could be dead from a myocardial infarction. and have to pump through, so you're going to have some very low blood pressure. Is that something we can fix in the field as an EMT? No. Is that something we're going to be able to recognize in the field as an EMT? No. What we're going to recognize is we've got a low blood pressure. What are we going to do to fix it? If it's low enough and they go unresponsive, we're going to compress for them, try to pump some blood, okay? Especially if it goes to zero. But hypotensiveness is an emergency that we're going to transport to the hospital. So I digress. No, really, I don't. That's just information, right? Good information, right? Y'all liking this yet?
Yeah.
I'm loving this. Yeah, I'm getting ready to do a jig. So the left ventricle, we already know that this pumps to the body. But it's got to go somewhere to get to the body. Where do you think it goes from the left ventricle? To a valve. Giovanni, you got it. Again, right here on this septum. Right there on that septum, there is another valve. What do we think we call it? We call it 11. The aortic valve. This, again, is on the septum, but I'm going to draw it outside the heart. Okay. It, again, is a semilunar, just like the pulmonary valve, because it looks kind of like half moons. So, if we go through the aortic valve, where do you think we're going next? Is it a given?
Arteries.
Aorta, there we go. So 12 is the aorta. So, tell me a characteristic of the aorta that's very important. Yes, but what else about it?
It carries oxygenated and deoxygenated blood throughout the body.
No. Aorta carries only oxygenated blood. It is the largest artery of the entire body. Okay? The aorta actually goes back through the septum, goes behind the left atrium, and comes to the top of the heart, and it looks like this. It's a big arch. And then it goes right down behind the heart in the mediastinum. We talked about that the other day, remember? Mediastinum right here. And it goes down, and it has smaller arteries coming off of it, and there is a diagram in your book, you don't have to open it up, of the major arteries, and it shows it comes down and it separates in the hepatic arteries, goes on down in the femoral arteries, but it separates. But in the mediastinum, it is very large. It's about the size of your thumb. Okay? The aorta is about the size of your thumb. The important thing about this is, where it comes out of the top of the heart, there is a ligament that attaches right here at the arch to the top of the heart. What do you think the purpose of that ligament is?
To keep it in contact.
To keep it in place, okay? To keep it there so when we move around, it doesn't flop around. The problem with that ligament is, in trauma, if I take a significant blow to a steering wheel, and that aorta, which is full of blood, which is as big as my thumb, goes forward, what can possibly happen?
Take a rip.
It can rip that ligament, which when it rips the ligament, it's going to take one of two things with it. Either part of the aorta or part of the heart. Either way, when it rips, guess what's happening?
Lots of blood.
You are losing a lot of blood real quick. Okay? The blood in your body, how long does it take it to completely circulate through your body?
6 minutes.
Less than a minute. Every drop of your blood circulates through your heart. Okay? As long as the heart's functioning right, your stroke volume is correct, your minute volume is correct, your heart's functioning like it's supposed to be, less than a minute, you're pumping all your blood through your body. Okay? So if I have a major tear, and all your blood's coming right out of your left ventricle, right? And it's going right into your aorta, so if I throw a big hole in there,
It's going to just spew out
where's it going to go?
into your body.
It's going to go into your thoracic cavity. It's going to mainly stay initially in the pericardium, okay, the sac that surrounds the heart. We talked about the other day, there's a condition that we have when the blood gets outside the heart into this pericardial sac. What's it called? Anybody remember? Cardiac tamponade. Okay? Because the pressure of the heart is pushing blood on the outside of it, so it's constricting it so it can't pump anymore. Okay? Anybody remember what the classic sign of cardiac tamponade is? How we recognize it in the field?
Heavy, like quick breathing.
No?
It's not
Something about the blood pressure. Yeah, you're right there.
It's
It quickly elevates.
Nope.
no, it's where the top one goes down, where the bottom one stays high. Like
Or goes up. We call it narrowing pressures. Narrowing pulse pressure is actually what it's called. Not plus. So say we first get to this person and their blood pressure is 145 over 75. Okay. They're going to have some chest pain, they're going to have some dyspnea, they're going to have some altered mental state, they're going to have all kinds of crap going on if this is happening. So at 5 minutes later, we do a reassessment because they're major trauma, and we see this thing now at 135 over 85. Do we need to be concerned? Yes. Okay? What concerns me about this is not so much the top number, because if I'm giving them oxygen and I'm calming the patient down and their need for oxygen has reduced because I've reduced their stress level, the top or systolic pressure could come down. Because initially they were hit with a dose of epinephrine or adrenaline, the fight or flight parasympathetic nervous system, and so it's going to elevate. Well, if I start calming them, this one could come down. But this one typically will stay the same. You're not going to see a lot of fluctuation in the diastolic because that is the resting pressure. Unless we're starting to squeeze the heart, okay? And that's because it's not necessarily in the venous system that's causing the restrictions, because it can't get out of the pericardial sac, okay? So if I see an elevation in the diastolic and a decrease in the systolic, I start getting concerned. So is that a good blood pressure? Yeah, I mean, it's not too bad. That's not death, okay? So, but it rings a bell. Boom. I could have something going on. If I'm going code 1 of the hospital, I'm just changing my transport mode to code 3, telling the driver, put that foot in the gas pedal, and let's get us there, lights and sirens, okay, because we've got something going on. 5 minutes later, I look at it, and I'm down to 125/95. I definitely can diagnose this patient as having cardiac tamponade. Now, depending on the severity of the tear, the rip, the hole in the pericardial sac, the hole in the ventricle, or the tear in the ligament, whatever caused it, I don't know. Don't care. I can't fix it in the field. It needs to go to the hospital. This could be rapid change or it could be a slow change. But this is one of the reasons we have to, every time, do a reassessment. Trauma is every 5 minutes. This is why, because the conditions of the patient can change rapidly, okay? This is something we have to learn to recognize. Because what's going to keep on happening, the more blood gets in there as the heart tries to pump. We're going to eventually come down to 0, 0. It's going to get to a point where it can't create any pressure, and you're not going to get anything. You're not going to get a pulse. So if you can't get a pulse, you're not going to hear anything, right? You're not going to feel a pulse. You can't auscultate a pulse. You can't palpate a pulse. You can't do anything. Okay. So, cardiac tamponade can happen when that ligament tears.
How do you spell that for cardiac tap?
Cardiac, C-A-R-D-I-E-C, TAMP, T-A-M-P-A-N-O-D-E, tamponade, something like that. Look it up. It's probably not right. It's in the book. Okay, so from the aorta, we continue our little journey into the body. Okay, the aorta is a what? Artery. Okay, it's the largest artery. So from the aorta, we continue into arteries. Huh? Okay, it's tamponade. So 13 is arteries. So we know everything gets smaller and smaller and smaller, right? It's just like a funnel. The aorta being the big part. And it gets smaller and smaller and smaller, right? So we get the aorta. We got the arteries.
Capillaries. Arterioles.
And then we have the arterioles. Arterioles or something like that is how it's actually, arterioles. Okay? So that would be 14.
What's 14?
Arterioles.
It's the best type of cereal out
Arterioles.
Staying away.
That's okay. So
Can you spell 14 for me, please?
Arterioles. Okay. So, from the arterioles, remember we get down to every cell in the body has the same thing the villi has, right? It has an arteriole around it, and it has another part of the system around it we're going to get to in just a second. But instead of calling a villi at the cellular level in the body, what do we call it? You said it a while ago. Capillaries. Okay? This is where everything comes together. Okay? Not air sacs like in the alveoli, but it's single cells. Literally, your body's made up of billions and billions and billions of them. We call them capillaries. Capillaries. Okay. What takes place at the capillaries?
Gas exchange.
Gas exchange again, right? We dump off all of our oxygen and we pick up all of our CO2. We get waste products where the cells have created energy, use ATP, and they start making lactic acid, and they make all those other byproducts. The blood picks it up. It's like the trash man. It goes through there and it picks up all this waste and it carries back through the body, drops it off at the liver, drops it off at the kidneys. We exhale the CO2, etc. Okay? So at the capillaries, we exchange oxygen-rich for what kind of blood now? Oxygen deficient or oxygen negative. So from the aorta through the arterioles, I'm going to say this is oxygen positive. Okay, so it's oxygen rich. So we're going to look at this hourglass again. From the capillaries, we've got to start our path back up the hill. I think I can. Okay. So it starts out real small again. And I'm changing colors again for a reason. Starts out real small, and then we actually grow again. So from the capillaries, number 15 would be capillaries, by the way. Did I write that somewhere? Okay, 15 is capillaries. So we've got 16. The smallest returning vessel out of the capillaries we call venules. Very, very small. Comes right out of the capillary beds. So from the venules, what do you think the next is? From venules. Veins, yes. So that would be 17. Okay. And so now we've almost completed our return back to the right atrium. So I'm going to draw this here and make this narrow again. And I'm going to connect that line, okay, on this circulation diagram. But from the veins, we go into a larger vessel that's attached to the right atrium. Anybody besides you, Anthony, want to tell me what that vessel is called?
Superior and inferior vena cava.
You got it, girl. Give that girl a hand. So the 18 is what we call the vena cava. V-E-N-A-C-A-V-A, vena cava. And we call it inferior and superior. Why do you think that is?
Because there's part of it's coming from your upper body, part of it's coming from your lower body.
The right atrium, where I've got this drawn onto the heart right now, I'm going to take part of this wall out. And if you actually look at a real heart, it looks like this. I'm actually going to take this away. Okay. Comes up. And this is a wide vessel, and it goes all the way up. And then this comes down right here. The right atrium and the inferior superior vena cava create that one cavity we call the right atrium. Okay? So all the blood from the brain and everything comes down this way. All the blood from the body and everywhere else is coming up this way. And it all meets right here in the right atrium. That, my friends, is the circulatory system of the human body. We've got the pulmonary circulation, which is the right side of the heart, which takes blood from the body that's deoxygenated, sends it through the right atrium, the right ventricle, into the lungs, aka alveoli, where it exchanges its bad gases for oxygen. Then it comes back from the alveoli into the left atrium, where it preloads the left ventricle, where we create our massive pressure for our systemic or systolic blood pressure, and it has to pump through the entire body. And then it comes back into the right atrium through the inferior and superior vena cava. 18 steps circulation system. If you have a problem in any of the 18, guess what happens?
We're dead.
We have a problem that we have to figure. The blood has to stay in the circulatory system. If it doesn't, what do we do as EMTs? Plug it, right? We try to plug it. We've got to keep the blood in there. Okay? If we don't have enough blood, we're going to haul ass. Right? If the heart's not pumping, what do we do for them? We pump it for them, doing CPR, right? If they're not breathing so that they're picking up oxygen here, what do we do for them? We breathe for them. Artificial respirations. So, we can keep this system working, but we've got to recognize a problem in that system, correct? Exactly. So, we've got part of it down. Clear? Understand? Make sense? Is it interesting? Yeah, I'm sure well better be. I love it.
One question though.
What's that?
You said the inferior vein cable brings the body from the blood back to the radiation, right?
Yes.
What is the superior?
From the brain and up.
The brain of it.
Your shoulders, your brain, all that. That's where it drains back into it. Let's take a break. Brace your brains for a minute because we're going to come back with some more good stuff in a minute.